Okay, so please let's assume this is our problem. Okay, so let's say this is A, and then this is B. Okay, the A is a ruler. A is a ruler. Because it has two balls under it. Okay, so that makes A a ruler. Unlike B, B does not have any ball under it. Okay, so B can be classified as a hinge support. Okay, please, my diagram is not to scale. Okay, so let's just manage. Then from there, okay, okay. So this is our given. This is our given. This become our given. This become our given. So we can um, label the part, then we start serious work. Okay. So please remember to always put the diagram down for an additional mark. Okay. Always do the given for 5 marks. No matter the time is going to, the number of your time is going to take, please always try to put it down so that you don't lose that mark. Okay. And here was 29.2 kilonewton meter. Kilonewton per meter. Okay. And here was 48. Let me say 43.8 kilonewton meter. 43.8 kilonewton per meter. Good. So from there, what else? Okay. So here is 4 meters. I think it was rather 3 meters. It was rather 3 meters. Here is 6. The middle was 6 meters. 6 meters. Then here was also 3 meters. Then the far end was just 3 meters. Okay. From there, we realized that there was a moment over here. And the moment was, you can see that it's just a point load at free end. Okay. Okay. And the point load at free end was 133.5 kilonewton. 0.5 kilonewton. I told you that the kilo means 10 exponent 3. Thank you. So here is the moment. Okay. And the moment is 1.4. Okay. That is kilonewton meter. Kilonewton dot meter. Because it's a moment. Moment is equal to force times perpendicular distance. Okay, good. So we are done putting our diagram down. Okay, as our given. So we just move to solving of the problem. Okay. So from here, where do we go? We move to our solution. Okay. But please, in a very big place, before anything, how many sections do you think we can divide this into before we begin to solve? Please, anyone to throw a little bit of that for us before we proceed with the work. Can anyone give us a brief of how he or she think, or how many sections he think we could divide the problem before we could be able to solve? Hello. All right. All right. So, without wasting much time, you realize that this could be divided into what? Three sections. Okay. So where here is going to be your one, then you can consider this aspect to be what? This is going to be your second section. Then this is going to be your third section. Okay. Good. Good. So we can move to our solution and then start to accelerate. Okay. So solution, we are coming to our solution. We just finished with our given. So we are coming to the solution. So this is our solution. Solution. And then in the solution, first of all, we want to pick just part A, or let me say the section 1. Okay, this section 1 over here at the top over here. So we are going to draw the section 1 then, or better still, we could draw all sections, then we pick them one by one and talk plenty about them. Okay, so if that is the case, let's bring all the sections out. Then we come and see how we could play with it. So this are section 1. Okay, so the section 1, this is how it's going to look like. So you realize that the span became what? Let me say 3 meters. Okay, and you realize the support was at what? A. The support was somewhere here. There was a support over here. Okay. Then let's also come and pick the other section, which is the section 2. In the section 2, you realize it was a UDL. The section 2 was a UDL. A UDL. Okay. And the UDL, it also has a span of 3 meters. Okay. That is the loaded length. That's the loaded length. That's the loaded length. Then let's consider the loaded intensity even before we move to the section 3. The loaded intensity over here, you realize that the first one is at the very top. I can see 2 loaded intensities over here. Okay, that is 43.8 and what? 29.2. Okay, good. If you want to know the loaded intensity for section 1, you have to subtract the 29.2 from the 43.8. Okay, and if you subtract 29.2 from 43.8, you are going to get 14.6. We're going to get 14.6 kilonewton, which is telling us that our load intensity for the first section is going to be 14.6 kilonewton meter. So that is 14.6, okay, kilonewton per meter. Kilonewton per meter. Kilonewton per meter. Okay, and then this one is just going to be what? 29.2 kilonewton per meter. Good. From there, what do we do? Okay, Kingsford, let me hear from you. You have a question. Please, you
Yeah,
can.
but I better
Okay,
go back. Why did we subtract instead?
very good. That was a very good question. And the reason why we are subtracting is that you realize that I told you that the only loaded diagrams or loaded they've taught it is a triangular load and a what? A UDL. So no
Yeah.
matter the complex figure that is given to you, you have to find a way to divide it into either a triangular load and a UDL. That is the only two you can get. Okay. And over here, we have been able to discover that there are three in here. Okay. You realize that the whole of here, from here up to here, from here up to here is what? Is 43.8 kilonewton. Okay. And
Yeah.
and you realize that the section one is on its own. Oh. So to get the ideal length of the section one, you have to subtract the 29.2 from what? 43.8 before you can get the original length of section two. Let's say that section two is shorter than section one.
Yeah.
So that is why I have to subtract the 29 from the what? 43.8 to get the 14.6. Okay.
Okay. Thank
Okay.
you.
Thank you too. So, okay, Afenyo Joseph, please, you have a question. Please, you can unmute yourself and ask.
So please, the other side, since there is a other load there, which is 133.5 kilonewton.
Oh, no, this is a point load. And you realize that in this case, we are only focusing on a UDL and triangular load. So those ones, we can forget about them. They just want to put it there to manipulate your life.
Okay, thank you.
You just focus on what you have been taught. What you have been taught now is what? A UDL and a triangular load. So if you go to the example, if you're not seeing UDL and triangular load, don't do anything apart from that. Okay?
Okay, okay.
Please, is anyone having any other question or we are good to go? Please, is anyone having any other question to ask or we are good to go? Okay, if no one has any other question to ask, then I believe we could proceed. Okay, if no one has any other question to ask, then I believe we could proceed. So in our section 3, this is how it's going to look like. It's also a UDL. Okay, it's also a UDL. It's also a UDL. This over here, the support was at A. Okay. Remember that in the main diagram, section 1 was on section 2. Okay. So in this one, if you want to calculate for the position, you have to calculate, you can calculate the position from only one point, that is the support, and that is the support. Okay. That is A. Okay. So let's let's go ahead to finish with the drawing of the section 3. Please, if you join, kindly mute yourself. Okay. Thank you very much. So this over here is also 29. The loaded intensity is 29.2 kilonewton per meter. Okay. So now we can proceed and make life much more easier. Okay. So from there, the next thing we are going to be doing is over here to you realize that the loaded over here to you realize that let's say this is support A and this is support B. Okay, so the section 3 has two supports. This support A and this support B. And the span is what? The span is, I think, 6 meters. So okay, so let's make a little bit of brainstorming before we proceed. Okay. The first one, you can only calculate for the position from A. The second one, you can calculate for the position from A to only position from A. But in the third section, you can calculate from the position from either support, from either A or B, because I told you that position is calculated from a support. And if you have two supports over here, you can choose the one to calculate for the position from. Good. So let's pick them section by section, and then we see how we can play with them. Okay. So first of all, let's do calculation of section 1. Okay. So I'm going to write calculation of section 1. So this is calculation of sec 1. Calculation of section 1. Okay. Good. And then in the section 1, our step 1, what is the first thing we say we are going to be doing? The first thing we are going to do in the section 1 is that our loaded length. Okay. First of all, what is part OA? First of all, in the section 1, our part A, let's say our part OA, is a what? Triangular load. Or let me say U fin L. Okay. And then the loaded length. The length is what? Our length over here. Our length over here is equal to
3 meters.
Yes, our length over here is going to be just 3 meters. Thank you very much. Then our intensity, the intensity. And the intensity is going to be what in section 1?
14.
Thank you very much. It's going to be 14.6. So this is 14.6 kilonewton. Kilonewton. Thank you. Per meter. So from there, where do we come to? We come to our ECL. So this is our ECL. Please, can someone tell me the full meaning of ECL? What is the full meaning of ECL?
Equivalent concentrated load.
Thank you very much. So because it's a triangle, you are going to just multiply half base times height. Okay. So half times what? The base is 3. Okay. So half times 3 times
intensity.
times 14. Yes, times intensity. Thank you. Times 14.6. Okay. So at the end of the day, what are we going to get? Someone should quickly do that for me. If you failure to add the units, will cause you to be penalized. So please, what are we getting? After punching, what are we getting?
21.9 kilonewton.
Thank you very much. So you're going to get 21.9 kilonewton. Okay. Then from here, where do we come to? We are coming to the position. So in our position, how do? We are going to we have to know whether the support is at the smaller end or the bigger end. Okay. Over here, you can see that the support is at the smaller end. So what are we going to use to multiply the length? What are we going to use to multiply the length? It's just 2 over 3. Okay. 2 over 3 times L, the length, so times 3. At the end of the day, what is our position going to be?
2.
Thank you very much. So at the end of the day, you are going to get, it's not 2, it's wrong. Anyone to tell me the correct answer?
2 kilonewton.
It's wrong. Anyone to tell me the correct answer?
2 meters. Sorry.
Thank you very much. Thank you very much. Thank you very much. I told you that if you fail to add a unit, I'll mark you wrong. So it's 2 meters. It's not 2. Okay. This is pure physics. So you have to add the meters. If you don't add the meters, you are totally wrong. Units must be added. So we are done with calculation of section 1. Okay. We also have to come and do the same for section 2. Okay. So we are going to pick section 2 and do calculation of section 2. Please, your exams is not going to be straightforward, as simple as you think. Okay. Or you may meet a complex structure like this, which you have to break into sections to be able to solve. Thank you very much. So this is the calculation calculation of what? Section what? Section 2. So this is our calculation of the section 2. Okay. Okay. So in the section 2, first of all, what is part OA? Can someone tell me what part OA is? What is part OA?
UDL.
Thank you very much. So our part OA is a UDL. Okay. So let me just write UDL. Okay. And then what is the loaded length?
It is UDL.
Yes, I've written UDL. What is the loaded length? What is the loaded length? The loaded length is just 3 meters. Okay. It's 3 meters. What is the loaded intensity? Load intensity. Load intensity. And our load intensity is equal to the load that is on this beam. Okay. That is 29.2 kilonewton. Okay. So what is it? It's equal to 29.2 kilonewton per meter. Kilonewton per meter. Then from there, where do we come to? We come to our ECL. From ECL, we come to position. Can't you see that this is the most easiest of all? So you come to the ECL. Okay. And the ECL is just length times breadth because it's a UDL. So what is it going to be? It's just going to be your 29.2 times 3. Okay. So we said that multiplication is commutative. So whether front to back or back to front, you must still get the same answer. So it's going to be 3 times what? 29. 3 times 29.2. Please, 3 times 29.2. What are we getting? Three times 29.2. What are you getting? I'm getting 87.6 kilonewton. So it is 87.6 kilonewton. Kilonewton. Okay. Kilonewton. Then you come to the position. So the position over here is going to be just half times L. Okay. So our half times the length, which is 3, is going to give us what? 1.5 meters. Okay. Please, anyone having any question to ask so far before we tackle the last aspect? Any question? Afenyo Joseph, please, you can ask your question.
The length from A to B, please, is that not 6 meters?
Yes, the length from A to B is 6 meters. Okay. The length from A to B is 6 meters.
But then
Afenyo Joseph, please calm down.
Yeah.
Calm down. Take a deep breath and come back again. We are on problem 2. Okay. We are on section 2. And did you see why I picked the section 2 from? Please, did you see why I picked? This is the one we are talking about, section 2. Okay. And the section 2 is in this part of the problem.
Okay.
Have you seen section 2? The section 2 is still under 3 meters. So have you forgotten? Have you forgotten the section 2 is still under 3 meters? Our section 2 is still under 3 meters. Okay. Better still see me one-on-one for more clarification, and I'll throw more light on that for you.
Okay, thank you.
Okay. So without talking much, let's proceed to our last section. Then we can come and draw an ECL diagram and wrap up for the day. All right. So this is our position for let me say section 2. Okay, good. And it was all from what? Support A. From support A. This one too was from support A. Okay, both of them. Okay. So let's do calculation of sec 3. Of sec 3. So this is section 3. Okay. And how do we calculate for the section 3? In the calculation of section 3, the part this time is going to be part what? It can be part
AB.
AB. Thank you very much. So part AB, our part AB, part AB is equal to what? Part AB, what is part AB? It's a UDL. Part AB is a UDL. Okay. Then we come to what? Loaded length. Loaded length. Loaded length. And the loaded length is equal to what? Please, what is the loaded length?
6 meters.
Thank you very much.
6 meters.
Thank you. It's equal to 6 meters. Then we come to the intensity, load intensity. Load intensity.
29.2.
Thank you. Load intensity. So in the load intensity, we are getting, you said 29.2.
Yeah.
So that's 29.2. I nearly marked you wrong. Kilonewton per meter. If you don't add the unit,
Yeah.
you'll be marked wrong. Okay, please, I'm not wickeding you guys, but I'm just trying to let you learn the hard way. If you go the hard way, you realize that in the exam, our life will be much more easier for you. So this is, from there you come to ECL. Okay, then the ECL is, because it's a UDL, you just length times breadth. So that's going to be what? 6 times 29.2. So please, someone should just point that on the calculator for me quickly. Failure to add unit to your answer will cause you to be penalized. Henceforth, your answer is going to be wrong. 6 times 29.2.
175.2 kilonewton.
Thank you. So your answer is, as a matter of fact, your answer is correct for 10 points. So you're getting 175.2 kilonewton. If I don't hear the kilonewton per, your answer is wrong. Okay. So we come to position.
Go ahead.
So the position is going to be, the position
Half times.
The position to this is going to be just, yes, thank you very much. It is half times L.
1/2.
Half times what? The length. So
6.
6.
6.
Okay. So this is, because it's a simply support, it's going to be mid span. So at the end of it, we are going to get what? 3 meters. Okay.
3 meters.
And this is going to occur at what? Mid span. Okay. Mid span. So from here, what do? You draw original problem. Then later, what do you come and do again? You come and draw your ECL diagram.
You draw the.
Okay. I hope you can all draw the ECL diagram on your own. Hello.
Yeah.
So should I leave it as an assignment for you guys to do and come and show me? So this was from A. From A. Okay. From support A. And then this one was also from A.
Support A.
Yes. From support A. This was also from support A. Okay. So from there, you only come and draw original problem again. Then from there, what do? You draw your ECL diagram and then you represent everything on it. Okay. Because of the time, in 3 minutes time, our link is going to go off. So what I'm going to do is that I'm only going to draw the ECL diagram then. Life can be much more easier. So from then, your next step, you what? Draw original problem again. You draw the original problem again. You draw the original problem again. Then from there, what do? You come to your ECL diagram. Okay. So this is how the ECL diagram is going to look like. I want to use about our last 2 minutes to draw this. Okay, then we could all wrap up for the day. So this is how the ECL diagram is going to look like. Okay. So this is the ECL diagram. This is a diagram. Okay. Then from there, you realize that this part was A. This was our part B. Then we come to the calibrations. Okay. In the calibrations, from here to here was 3 meters. From here to here was 6 meters. And I think from the last one again was another 3 meters. Okay. Okay. Here was 6 meters. And here was 3 meters. Okay. So the position for the first one that we draw, it was 1.5. Okay. So you measure 1.5 from this, from here. Okay. And if you measure 1.5 from here, it's going to be at a mid span. Okay. So this is your 1.5. Okay. So over there, you realize that, let me say, your reaction, which is your ECL, can be somewhere here. Okay. And that ECL was 87.6. 87.6. 87.6. Then the other one was, I think, 2 meters. Okay. So from here to here, 2 meters. Then you put it over there. And that one was also what? 21.9. 21.9. Okay. Kilonewton. Kilonewton. Then the last one was at mid span. Okay. So the mid